Hello everybody and welcome to week 5 in geometry. Make sure you've got your math notebook out. Remember, you do need to take notes as you watch this recording. That is part of the requirements for your weekly notes, and half of your grade from your weekly notes does come from taking notes from this recording. So make sure you're taking good notes and label them in your notes. When you go to take your notes, label it. Put it at the top of wherever you start to take your weekly recording notes. Label it week 5 recording notes so that I can quickly find those when I'm grading. If it's hard for me to find your weekly notes in your notes that you're submitting, you might lose points because I can't tell if you took notes for your recording. So if you label them, it's going to make it a lot more easier on me and then easier on you to get those points. So make sure you're labeling your notes from the weekly recording as just that, week 5 recording notes, as a headline. All right, so we are starting a brand new unit, Unit 6. You should have already taken the Unit 5 test. If you have not, you might want to take the Unit 5 test so that you're focused on Unit 5 before you start this recording, before you dive into a brand new unit. Kind of keep those two separated. And remember, since we are taking the Unit 5 test this week, make sure you get your redos done this week from Unit 5. I won't accept redos from Unit 5 after this week since we're starting a new unit. So just a heads up about that you can still complete redos for this week, but after this week I will no longer accept redos for Unit 5. All right, jumping into a brand new unit, Unit 6, and guess what? It's all about probability. That's why I have a picture of these marbles, because we know when we look at probability, we always have 1 or 2 questions about marbles, right? So what does the word probability mean to you? And if you want to jot down in your math notebook what you think probability is and what do you think you're going to be learning about in Unit 6. So take a moment, click pause, and jot down some thoughts about probability. All right, so probability is the chance that something will happen. So it's the likelihood that something will occur. And we are going to be learning about looking at probabilities of different events. We'll look at probabilities of something that we think is going to happen based on actual events that we look at. And then we'll look at the probability where we look at the probability of something that's expected to happen. And we're going to look at, well, let me back up here again. Probability can be expressed using fractions, percents, or decimals. So we're going to be looking at that in this unit. If you have something that's impossible to happen, we would say the probability that something impossible is going to happen is 0. And then the more certain something is going to happen, it gets closer to 1 or 100%. So really, again, probability is just the likelihood of, or the chance that something will occur. And we're gonna look at that a lot more detailed as we work our way through Unit 6. So this week, I put the order of the slides a little bit different this week because, like I said, I want, you're going to take the Unit 5 test, and this recording is all about Unit 6 and Intro to Probability. So I thought it would be more helpful for you to take the unit test and then watch this recording. So if you started this recording and you have not watched the Unit 5, or you've not completed the Unit 5 test, that is okay. But you're going to be kind of toggling between 2 units, and that might get a little bit confusing. So you might want to stop watching this recording if you haven't taken the Unit 5 test and focus on Unit 5, be done with it, and then start this recording where we're going to look at the Intro to Unit 6 and probability. So you'll start with taking the Unit 6 test. Remember, it's a pre-test. It's a Unit 6 pre-test. You will get full credit for completing it no matter how you do. Remember, it's just a pre-test. And what's cool about pre-test is it gives you an idea of what you're going to be learning. You also can look to see how much you might already know and what you still are going to learn. And then what's cool is when we're done with Unit 6 is thinking about how far you've come from taking the pretest to the end of the unit and how much you've learned. We're going to start Unit 6, Session 1, which is all about theoretical and experimental probability. And by the end of this recording, you will be able to tell me the difference between these two terms, theoretical and experimental probability. Let's jump right in. I know this is not the first time you have looked at probability in math. So this equation where we find the probability of event probably is going to look familiar to you. So what might look a little unfamiliar is some of the way that we write probability equations. So up here, the probability of an event A, so if we're trying to, let's say we've got some event and we'll call it a generic event A. If we want to find the probability of event A occurring, we're going to write it like this. We would say P, capital P, and in parentheses A. That means probability of event A. And then how do we find the probability of an event? Well, we find the number of ways that event A can occur, and that number is going to go on the numerator. And then on the denominator, we're going to put the total number of possible outcomes. The total number of possible outcomes. On top goes just the number of ways that certain event we're trying to find the probability can occur. So what do I mean by that? It's so much more helpful to look at examples sometimes. So we've got a picture of some really cute puppies down here, and I want us to find the chances or the probabilities of picking a yellow lab from this bunch down here. So if we, what is the probability that we might go home with a yellow lab? Well, so we're trying to find the probability of a, and I'm going to put in parentheses, yellow lab. So capital P, and then yellow lab is what we're trying to find the probability of. So how many different yellow labs are there? How many yellow labs are there? So how many different yellow labs can we choose from? 1, 2, 3, 4. There are 4, so that's going to be on my numerator. And then my denominator is the total number of possible outcomes, or how many dogs are there, puppies are there total. Well, there's 1, 2, 3, 4, 5 total dogs. So the probability of choosing a yellow lab is going to be 4 out of 5. So I mentioned briefly in my intro that we can write probabilities as a fraction, and that's what we have below right now. We can write it as a decimal, right? We know we can go from a fraction to a decimal. If I divide 4 divided by 5, I would get 0.8. So we can also write it as a decimal, and then we can also write it as a percentage. So there's 3 different ways that we can write probabilities, as a fraction, decimal, or as a percent. And to go from a decimal to a percent, we would move our decimal 2 places to the right, and it would be an 80% chance. So a quick intro to probability, and just reminding ourselves how we find an easy probability question like this, and that we can write it as a fraction, decimal, or percentage. And then again, how do we write, or looking at the notation that we use. So you're going to see a lot this week and throughout this unit that capital P with parentheses, and whatever is in that parentheses, that means the probability of whatever it is you're trying to find. So making sure that we're okay with the notation of probability as well. I'm going to go to the next slide, so if you need more time, go ahead and click pause. All right, so 2 vocab words, theoretical or experimental probability. There are 2 different types of probability, and we can find the probability of each type. So theoretical probability is what we expect to happen. It's just what we expect to happen. And a great example of theoretical probability is this first example here of when we think about tossing a coin and getting heads or tails, well, we know that the probability of getting a heads or tails is 50% for each. That's based on what is expected to happen, or the theoretical probability. So theoretical is what is expected to happen. Whereas experimental probability is the probability based on trials, on actual trials. So if we were to, let's say, grab a coin and toss that coin 20 times and write down on each toss if it was heads or tails, and then based our probability off of those trials, that would be experimental probability. So experimental probability is actually the probability based on a bunch of trials. So now let's look at these three examples down here and decide if the example would be an example of theoretical or experimental probability. So first one, if we toss a fair coin, what is the probability that a tail will show up? Well, that's based on what is expected to happen, 1/2 chance. So that one would be experimental. Or I'm sorry, I meant to say theoretical. I grabbed my green for theoretical and then I said experimental. So that's theoretical. It's based on what is expected to happen. Let's look at this second example. It says a bag contains 20 marbles. 15 of them are red, 5 of them are blue, and we want to find the probability of picking a red marble. So that probability, would that be theoretical or experimental? What do you think? If you said theoretical, you are correct. We would base that on what we expect. And anybody know what the probability of that would be? Well, we want to find the probability of choosing a red marble. So our notation would be capital P with R in parentheses to say we're trying to find the probability of a red marble. Well, how many red marbles are there? 15 are red, and then how many total marbles do we have to choose from? 20. So the probability of choosing a red marble is an example of theoretical based on what is expected to happen and would be 15 over 20. We can reduce that. If you're saying that, yes, you can. Divide out a 5 from each and we would get 3/4. 15 divided by 5 is 3, yep. All right, the last one. You use a simulation tool to find the probability of rolling a 3 on a dice. You roll the dice 50 times to collect data, and then we would be finding the probability of rolling a 3 on dice using that data that we collected. Is that theoretical or experimental? In this case, if you said experimental, you are correct. We are basing the probability off of the actual data that we collect. So it's experimental, based off of the data that we collect, or the trials. All right, moving on to the next slide. So if you need more time, go ahead and click pause. All right, so we're going to actually find some probabilities now. We're going to find some theoretical probabilities and some experimental probabilities. So let's look at this slide. It says an aquarium is stocked with a bunch of different kinds of fish. We've got 25 neon tetra fish, and I'm going to use a capital N to represent the neon tetras. There's 18 sword tails. I'm going to use a capital S to represent the sword tails. There are 12 platy fish, capital P to represent, and there are 3 catfish. Use a capital C. So we've got 4 different types of fish and the numbers of each of those. A geometry class, just like yours, is on a field trip at the aquarium and is recording the number of fish that they observe in an aquarium, in a fish tank. So they're standing there and they're recording, they're counting how many of each fish they see. So during a 15-minute period, the class observed 18 neon tetra, 10 swordtails, 9 platy, and 2 catfish. So remember up here is the total number of fish in that fish tank, and then down here is the numbers that the students were able to observe and record. All right, so we've got essentially two sets of data, right? So on the left here in the purple, it says determine the experimental probability of observing a neon tetra. So the experimental probability. So which data would we use? Would we use this data up here or this data down here to find the experimental probability? So remember, experimental probability is based on trials or data that you collect. So we are going to use this data right here. The data that we collected is what we are going to use to find the experimental probability. We're going to use this data. And we want to find the probability of observing a neon tetra. Remember, we're going to use N for neon tetra. So probability of N. What would be the probability of N, the experimental probability of observing a neon tetra? What do you think it would be? Again, remember, we're going to use this data that we collected during our 15 minutes of observing. So there is a total number of 18 neon tetra. Out of how many total fish were there that we observed? Well, we observed a total of 18. The total would be 18 plus 10 plus 9 plus 2. Add that all up. 18 plus 10 is 28. I'm going to add that 2 in there for 30, and then that 9 for a total of 39. So that's going to be in our denominator. So the probability, the experimental probability of observing a neon tetra would be 18 over 39. That is a fraction form. Sometimes it might say express your probability as a decimal. If you wanted to express it as a decimal, we'd take 18 and divide it by 39, and I would get 0.46. If I wanted it as a percentage, I would just move that 2 decimal places to the right and get 46%. Now let's switch gears and look at the theoretical probability, of observing a neon tetra. So theoretical is what we expect to happen. So we're going to use the data up here at the top as our theoretical to help us find the theoretical probability. If you want to click pause and try this on your own and then check your work with mine, you're welcome to do that. So again, we want to find the probability of a neon tetra, so I'm going to put capital N because we established that up here. N represents neon tetras. How many neon tetras can we choose from? 25. And then how many total fish are there in this tank? We'll add all these up, so the total is going to be 25 plus 18 plus 12 plus 3. So 25 plus 18 is 43 plus 12 plus 3. So I'm just grabbing a calculator now and I'm going to plug all these numbers in, and when I do that I get 58. That's going to be on my denominator. So that is my probability, 25 over 58. If I want to write that as a decimal, I'm going to take 25 and divide it by 58, and I get 0.43. And if I want that as a percentage, move that decimal 2 places to the right to give me 43%. So we can find different probabilities based on whether we're looking at a theoretical event or an experimental event where we are collecting data and basing our probability off of that data. So that is it. All right, so we're ready for the week 5 key phrase assignment. This key phrase assignment is going to be based on some data collected by a student. So a student is keeping track of tossing a coin up and whether the coin lands on heads or tails each time. So each time it lands on heads, marked over here. Each time it landed on tails, it was marked over to the right. So there's 2 questions I want for you to answer. The first one is based on this tallying and the data above. What is the probability of tossing the coin and it landing on on tails. So that's your first question. The second question is this an example of experimental probability or theoretical probability? And how do you know? So again, first question is, what is the probability using this data above of landing on tails, of tossing a coin and landing on tails? That's the first question. The second one is this an example of experimental or theoretical probability, and how do you know? And that is it. As always, if you have any questions as you're working through this week's material or assignments, let me know. Remember, I can't help you if I don't know the questions. So please reach out when you have questions. And as always, have a fantastic rest of your week.